Okay guys, here we go again. We've got a video for you on solving linear inequalities. Alright, and the reason why this is different is right here. Instead of an equal sign, we have an inequality sign. So that is the big difference between what we've been doing the last couple days or weeks with y equals mx plus b. We're still going to use that today. But it's a little different. We got to add in some more things because of that inequality. So let's jump right into the first thing here. Tell whether the ordered pairs is a solution. If you remember when this was an equation, to tell if something was a solution, well, you simply plugged it in to the equation and you see, did it work? Alright, so we're going to do the same thing. Alright, I already have my x and my y labeled over here. So if I plug a 3, 0 into this, I'm going to plug a 3 in for the x and a 0 in for the y, and then I'm just going to do the math. Alright, 9 minus 0 is 9, and I get 9 is greater than 2. The difference here, it's not an equal sign. So you say to yourself, really the same thing as what we did with the equal sign. Is this true? Alright, and hopefully we all know that 9 is in fact greater than 2. So our answer is yes. That means that this coordinate is in fact a solution to this inequality. Alright, really that is all there is to this part. Do the same thing with the -1, 5. If I plug in the -1 for x and the 5 for y, I get an answer like so. I get -8 is greater than 5, and I say to myself, same thing. Is this true? Well, hopefully we all say -8 is not greater than 5. So no, that is not true, meaning no, that is not a solution to this inequality. Alright, so that's a pretty easy thing to start out with. You have a couple on your next page as a checkpoint. So I'm going to put the answers up, and you can pause it as much as you need to, but that's the solutions worked out. So hopefully you're able to get those. And I'm going to go right on to the next example. Now here we take it a step further. We want to graph this. Alright, and this is going to be very similar to what we've done with y equals mx plus b again. I'm just going to write this over. The software that I'm using does not allow me to write that symbol. Okay, that's what this is supposed to be. Okay, greater than or equal to. So I'm going to write it like that. Alright, so the way we start is the same thing we've done before. I need my slope. Remember, y equals mx plus b. It's already in that form. So here's my slope. Slope is right there. That's equal to -1, which we usually write it as a fraction. Okay, and here's my y-intercept, and that is equal to 1. And again, we usually write that as a coordinate, 0, 1, and then we go graph it. And this is all the same. Alright, we haven't done anything different than we usually have. So I'm going to go graph this, and I'm going to put a few points up here, 0, 1. There's my y-intercept. And a slope of -1 means I just put a bunch of points down and over. Okay, now here's where it gets different. Okay, number 1. You could have a solid line that you're going to draw, or you could have a dashed line that you're going to draw. And there's no cutesy way to remember this. Alright, if you have this symbol, I did it again, I did that last time. If you have this symbol or this symbol, alright, it is a solid line. If you have this symbol or that symbol, it is a dashed line. Okay, you just have to know that. Alright, there's no cute way to do it. So we have this symbol. So we are going to draw ourselves a solid line, and I'm going to try to make this as well as I can here, going through the points that I want. I know I got a slope of -1, so I should hit these every time. And I'm going to go back here the other way and do the same thing. should hit those right in the corner every time. Okay, oops, little hiccup there. Alright, so that is pretty easy. If it were one of these, I'd just do the same line, but I'd have a bunch of spaces in it. It'd be a dash. Alright, now number two, when you have an inequality, you have to shade one way or the other. Okay, so I'm either going to shade all of this, or I'm going to shade all of this. Okay, and the way you figure that out is you try a point. You try a point that is not on that line. Okay, and here's what I do. If 0, 0 is not on that line, that is the easiest number to work with. So I usually try 0, 0. Okay, sometimes you run into them and it goes right through 0, 0. You have to try a different point. If that's the case, I usually go like 1, 1. Alright, what's easier to deal with than 1? Alright, but this is a case where it doesn't go through 0, 0, so I'm going to try a point. I'm going to try 0, 0. Okay, so I go to my original inequality, which looked like this, way up at the top, and I plug in a 0 for each x and y. Alright, now I know that there's no such thing as negative 0, but I'm just making a little emphasis here. 0 plus 1 is 0. And now I do the same thing as I did in the first examples. I say, is this true? So, is this true? Okay. And is 0 greater than 1? Well, no. Alright, it is not true. That tells me which side to shade. So I try to point over here on this side of the line. If it came up true, I would shade that side of the line. I would shade the same side. But since I try to point here and it didn't come up true, then that tells me go to the other side. So in this case, I shade over here. And here's all you have to do to shade. You don't have to shade the whole thing like you're coloring. I know it's fun sometimes, but this is all we do. Mathematicians, that's all we do. Okay? So again, if it would have come up true, since I tried a point on this side and it came up true, I would then shade over here. But since I tried a point over here and it didn't come up true, I go to the other side and I shade that in. Alright, so those are the big differences that we add in today. Okay? So hopefully that was good. If you need to, go back and watch it again. You know, that works really well. So I'm going to get rid of this one. And I'm going to go up to example 3. And okay, so here is example 3. And I'm going to flip over to red since this started in red. But here we have 2 inequalities. Now, the reason why I want to do this example, the reason why we want to point this out is these are kind of special cases. If you remember, when this was x equals negative 2, remember that was a vertical line. There's no y in the equation. And when this was y equals 3, that was a horizontal line. Okay, there's no x. So these are, we don't have to worry about slope or intercept. As soon as you see something, there's no y in there, that means the x's have to be this negative 2. Okay, so I can just make up some points. And y's can be anything, so I'm going to make them real easy. 0, 1, 2, 3. Okay, and if I go over to shade to graph those, now remember, this I either have a solid line or a dashed line, and if you remember from before, this symbol gives me a dashed line. So if I graph these points, that's here. I'm not going to make them very big this time because I know I'm going to put a line through there, and I know it's going to be a dashed line. So I'm just going to, you see, it's going to be a vertical line right along there. Okay, so I'm going to try to draw this in here. It's going to be right along here. Oh, that's terrible. Ugh, let me fix that. Alright, let's see if I can do that a little better here. It's going to be a dashed line right along here. You guys laughing at me. You think this is easy. This is not easy. Things I do for you people. Alright. Yeah, these are really supposed to be straight. Oh, that's a little better. Maybe I just do them quicker. That would be better. Okay. Alright, so there you go. Now, you can't ignore the other part though. We gotta shade in one side or the other. Alright, so I go over here and I try 0, 0. Okay, Okay, this does not go over 0, 0. So I plug in a 0, and I say to myself, is this true? Is 0 greater than -2? Well, that is absolutely true. Okay, so if that is true, 0, 0 is here, that's the point I tried. That means I would shade in that side. Since 0, 0 is over here, I tried it, it worked, so I would just go like this straight across. And usually when you make these, you come like perpendicular off the line. Alright, just like that. If it was a diagonal line, I'd be like at a diagonal like the one I did before. Alright, so that is it. Now this is going to get a little messy because we're going to do another one right on top of that. Okay, so we're going to do this one. This is the case where there are no x's in the equation. And remember, this is actually less than or equal to 3. Okay, that's what this symbol means right here. Okay, so this means y has to be 3. There's no x's. Alright, x can be anything it wants. So again, take real easy cases here. Whoops, yeah, I can count. Okay, so anyway, I'm going to graph these. Again, I'm going to make them real small because I know I'm going to draw a line here. So 0, 3 would be here. 1, 3, 2, 3, 3, 3 is there. Okay, and this symbol, if you remember before, that means a solid line. So I'm just going to do a solid line. Hopefully this one goes a little bit better. There we go. Okay, that's not too bad. Alrighty, now I want to try to see which side I'm going to shade. So I try 0, 0 again. Okay, and I plug in a 0, and I get 0 is greater, or 0 is less than or equal to 3. And I say, is that true? Yes, that is true. Okay, so again, 0, 0 is on this side. It came up true, so I shade all of this, and I'm trying to go perpendicular to that line the way I shade. Okay, and so what that tells you is anything in this shading, anything in this red shading is a solution to this one. Anything in that green shading is a solution to that one. And if you really want to push the envelope, if I say, hey, where's the solution to both, then you want where they overlap. Okay, and if you get what's going on, then that's not too difficult for you. So, all right, let me turn that off. Again, you have another checkpoint. All right. Again, I put 2 graphs on the same because that's the way they have it listed for you. Actually, they give you 2 graphs, but I did mine on the same. But if you want to look through my solution, once you do yours, there it is. So you can pause it and check it out. Alright, and I'm going to go on to, well, yeah, that's it. Hey, that's it. That's all we got in the packet for tonight. So hopefully that made sense. I know that is very different with all this shading and trying one point or the other. We'll practice some more tomorrow in class. But please, 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 if you're not sure of something, go back and watch it again. I think I did pretty good. This one wasn't too. How long was this one? Looks like it's under 15 minutes. So I'm going to turn this off and